So, participants, good afternoon, everyone. So,
good afternoon, sir.
Good afternoon. So, I am welcoming the second afternoon session. So, mostly afternoon session after the lunch, here is sitting the session or hearing some lecture is definitely we will feel bored because we are faculty members. So, anyway, I will try to make it is some interesting manner. Okay. So, morning we discussed the what is the data science, what is the impact of, what is the importance of data science, then what is the machine learning. So, what are the various machine learning algorithms are there? Then the machine learning things, what are the things, what are the sequence we got to do? So, first thing is once we gathered the data, we have to do the data pre-processing. So, before you are going to apply the any one of the machine learning algorithm, so we have to do the some the data pre-processing. Okay. So straight away go to that presentation site. So I will show some demo on that data pre-processing. I will show one. So are you able to see my screen? Hello?
Sir.
Are you able to see my screen?
Yeah, it's visible, sir. No problem.
Okay. So this is the one of the simple Python coding I will show on the data pre-processing. I hope everybody you are using the Colab. So it is one of the very good platform. Anyway, you can run in that normal Python in the command prompt also, or you can run in that Anaconda setup also. So I feel more comfortable in that we using that Colab because it is we are not using the our machine, we are using the top of the one cloud environment. So we are running that your program in Jupyter notebook environment in the Google cloud. In the Google they are providing on the Jupyter notebook environment. So that is we called as a Colab. So why it is more comfortable in the sense, in one aspect, that is suppose if you are running the some deep learning problem, so that means we have to run the separate, create the separate environment for TensorFlow or Keras. So for that, if you are using your normal Python or if you are using the Anaconda, then definitely you have to face a lot of issue will be there. You have to format, you have to delete all the existing environment, you have to create a new setup. So, but while you are running that, you are executing the deep learning problem in that Colab means, so no need to do anything. Already every library is inbuilt in that particular Colab. So no need to install, no need to create any separate environment. So automatically it will run. Okay. So, and I hope in the last 2 days you have the data science, some find the library also. Yesterday your afternoon session, I hope you learned a lot of the basics about the Python and others. So Python is one of the very good tool or package normally used for the data science. Okay, you can use R also, you can use Wake also. So that up to you. I'm not forcing you to, you have to do in Python only. So, but I feel more comfortable on Python because lot of inbuilt in library also there is, no need to for more coding. And another one important things, you don't worry about that the implementation part. It is just like a plug and play. So whatever the models, whatever the library classifier there, all the things already ready made, it will available. You got to plug and run. You got to plug the model, give that input data set, you run the model, automatically you will get the result. So no need to worry about the coding part. And a lot of demo documentation help, YouTube video link also there. You can easily learn that Python. So it is not difficult to learn the Python or implement the coding part in the Python also. Okay. So this is the one simple stage, data pre-processing. Okay. So data pre-processing, the sense how to do the pre-processing, then how to handle the missing data, how to identify the outliers, how to data transformation, how to transform the data. So these things we have to discuss with the help of the one of the simple problem, simple exercise. So first thing is we have to already run the code. So I will not take more time because we have to discuss lot of things are there. So we have to import the required library. So import pandas and NumPy. So these are the most dominant packages library mostly used for the when we are doing the data science things. Okay. So and another one thing is I loaded all my program into my Google Drive. So we have to take the data set is under the program notebook program. So the Python program, everything I am running on the top of my machine. So that is a Colab environment. So for that, first we have to mount your drive. We have to mount your drive. So for that, this is the command for mounting the drive. Okay. So another thing is I'm reading on data. I'm reading the one data. So this is the file. This is just I simply created the Excel file. It is not I didn't downloaded anything. So for easy understanding level, I created one database. So what is that one Excel sheet? So here employee ID, age, job, education, salary, marital status, own house, other loan, bank balance, CIBIL score, loan sanction. So this is the one of the simple data set. So I am using for whether we are applying the bank loan, whether your application is sanctioned or rejected. Okay. So here the last column is the your loan predicted output. Already morning we discussed this is the dependent variable. So this is the your output predicted variable. So when we are applying the, when we are asking the loan for the bank, so they may ask a lot of details, whether you have the government salary, whether you have the what is your job, whether you have any other loan, so what is your CIBIL score. So they may check the all the lot of parameters. So after analyzing the all the parameters, then only they may decide that whether we have to approve or reject the loan. Okay, so this is the data. Here you see here some of the cells are I am purpose missing. So missing means I purposefully I didn't enter the value. So it is not a original data set. I only entered the value, myself only entered the value. So purposefully I didn't enter the value because so these are the cells, meaning that it is a value is missing. 1 minute, 1 minute. Hello. Yes, brother. Yes, brother. You come back. I'll take. Your room. I'm taking one class. You send somebody. Okay. So sorry. So these are the values. Is the missing value. So wherever the cell, some of the values are there, it is a missing value. So how to handle the missing value? How to handle the missing value? One part. And some of the values are categorical data. So this is the categorical data, and some of the data it's having the some long range also there, small range values also there. Yes. Okay. Okay. Close it. Okay. So how to handle the data? So whenever there is, because when we are given the input to the machine learning algorithm, so the system will read only the binarical data. That means it's only the numerical data. So whatever you are having the categorical data is there. So definitely the categorical value should be converted into the numerical data. It's correct. So because machine is understand only the numerical. Machine doesn't know about the categorical value. So whatever your values are, categorical values are there, that value you have to convert it to the numerical value. So wherever your values are missing, they have to filter how to handle the missing values. And whenever the range of values are not huge range of there, we have to normalize the data within the 0 to 1 or minus to 1 according to our wish. So these are the things we got to going to do in that our data pre-processing step. So this is the my input data. Okay, so I am reading the same file. I am reading the same file only. So whenever you want to read the CSV file, so we got to use the data frame. So data frame is mainly used for handling that your CSV file format. So for that only we got to create the data frame. The name of the data frame is DF. So DF I created with the help of the pandas. So I import the pandas. So I'm importing pandas. Using the pandas, I'm creating one data frame. So these are the, I will not explain more commands about the Python commands. Already I hope you know the Python command. Otherwise, you can usually get it from the help of the YouTube or some other open site document also there. Or I will share some of the pandas or books also. I may share some of the Python based books also there. Some Python tutorial books also there. I can share the books also to you. Please you go through and you practice it. It is not a difficult task. Okay. So this is the I'm reading the missing file. You see here some of the values wherever the Excel sheet the values are blank value. The blank values are here already filled with some value NaN. So NaN means it is not a number. NaN means not a number. By default, whenever your Python is reading the value, reading the CSV file, default itself it will fix it, filling with the value. So filling the values, we can see wherever the values are missing. So that values are already filled with the NaN. So NaN is nothing but it is a missing value. It's the missed value. But your Python replace the missed value with the NaN. So NaN is nothing but it is not a number. So this is I am opening reading the file. Now my Excel file is available in the DF. So DF is nothing but the one data frame. You can use any one of the name. It is not a mandatory. You got to use the DF only. So first I got to check that the handling the missing value. Any value is missing in the particular whole database. You see here the attributes are small. There is some 7 to 10 attributes there. Record also I am having only 20 records there. But a real scenario, you have the huge data set. If you have the huge data set and you have the more number of records will be also there. Then it is not you have to manually. It is not possible to identify the wherever the values are missing. So we have to use the some commands. So here some of the commands are there. One is a is null, another one is a not null. So is null means any value is null. Is null means it will say is null. We are asking is null yes or true. Yes means whether there is a value. Wherever value is we have to the value as a true. So rest of the value it will give us a false. Okay, so here this is the true value. Where the values are missing, so that values we can identify as a true. So where the values are there, so that it will give us a false value. So this is the, I have to check whether any null value is there. If all cells are false means that meaning there is no null value. Suppose all are true means completely values are missing value. So this is the one way. Okay, because I am checking that whether is null. Then I am checking that is null sum. What are the attributes are having the missing value? Age, how many missing value? Job. These are the attributes. Which of the attributes are having a missing value? Here you see employee ID 0 means there is no missing value. Similarly, loan sanction, that is a last predicted output value, the target variable value. So that also there is no missing value 0. Okay. So and another thing is for salary, particular one attributes I am checking. So you may practice yourself. I am using the salary. You got to use some other attribute also, or you can combine some other attribute with this attribute also. Salary is null. So these are the salary record. You see salary, the field having the null dot shape. So it will give the how many checking is used to missing values there. Okay. Then the drop null values. So drop means we are dropping null values. Okay. I am not able to fill the values. So automatically we have to drop the null values. That is also one option. Handling the missing value. One way we have to identify wherever the missing value is there, we have to fill the missing values. Okay. After I am identifying the missing values, I don't want to take any risk. I don't want to fill any values. Simply wherever the drop missing values are there, simply I can drop that. So that
Arul sir, voice.
drop not me. So drop is the method used to find used to the are used to do the missing values. Okay, that is the method of drop. So drop any. So any means if any null is present, drop that row or column. Wherever the any is missing, whether it is a row wise or column wise, we have to miss. Okay. So here you
Your
see
screen
I
is
am
not visible.
using.
Sir,
Hello.
your screen is not shared.
Wait.
No, the voice and screen was coming perfectly fine, sir.
Sir, already it is not showing.
Now it has stopped showing. Before it was working. Now it has come up.
Now it is visible.
Yes, it is visible and you are audible too.
No, it is not visible to me. Some problem at my side.
No, because,
Okay. We take it, sir. So what about participants?
Yeah, it
Are
is
you
visible, sir. It is
yes,
visible.
yes,
Yes, sir, it's visible.
okay.
I can
Okay,
see the
You
Okay, sir,
proceed.
position.
please take your please.
okay, sir.
Okay. So in case, so you see wherever I'm applying the command, so you will not reflect in that particular database. Your origin of the source of the data. Your in place is default, your in place is false. In place false in the sense. So whatever we are, this is the understanding process. The itself the command will show the result, but it will reflect in the original data backend. That means our in place is by default it is false. If you want to execute the command will reflect in the database, you give the option in place equal to true. Not whatever we are doing the command here, it will automatically reflect at the particular field. Okay. So using the drop in a subset salary, any field having the salary have the null values and dropping. So totally three rows, three fields have that. And so both the cells we are now have particular data. Okay. After wrapping, what is the how many records are there? Probably we are having 17 records and 11 records. So these are the commands. Normally, I will go to the notebook backward fill value. So these are the options we have to use to the how to handling the missing values. Identify the missing value, whether we want to drop the list value or we want to fill the missing value. So we filling the missing value, the method is fill NA. So we have to use some of the methods. Okay. So these are the backward fill. I apply with the some more attribute also, you practice that. So these are the things, first part, how to handling the missing value. Second one is that pre-processing. Okay, the data pre-processing already told you. First, we have to identify the missing values. Okay, I am identified the missing value. Then, wherever you have to convert, because we are giving the data to the your machine learning algorithm. So in the algorithm, will read only the numerical data. So first thing is, wherever you have the categorical data, you have to replace all the categorical data with the numerical data. Where suppose your categorical data is nominal data, then you have to handle separate way. Your categorical data is some ordinal data. So morning we will discuss what is nominal data and what is ordinal data. Then we have to convert into the numerical data. So method is same, but you have to assign the number in some meaningful way. The categorical data and the nominal data, we got to substitute with the number. But when we are assigning the number, if you are the ordinal data, then we have to some logic should be there. We cannot randomly assign the number. For example, yes grade means number 10, or rating. I want to rating is there, ABCD is there. So high rating, I got to fill number 5. Next rating number, I have to give 4. Some numerical, we are assigning some numerical value, but the numerical value assignment, some logic should be there. We got to use some meaningful way. So that is the meaning of how to handle the categorical data and the nominal data. Then we got to do the data transformation also. Okay, so same data set only I'm taking, your employee ID J is the same data set only I'm taking the value. So here you see the job, education, marital status, so and the own house and other loan. So these are the values are categorical value. So we have to convert the categorical value into the numerical value. So that only we have to, then only we can able to process. The head command will display the first 5 records. The tail command will list the last 5 records. So these are the things are the basic Python commands. You can easily understand. So first I am checking that what are the columns are there. What are the columns are there. Okay. Then I want to check that in the marital status, that is a particular one attribute. What are the unique values are there? So the unique values, married, single, divorced. So total 3 values are there. So now I want to, this is a categorical data. I want to convert into the numerical data. So I am defining one function. I am defining a one function. Okay. Using the function, you see, whenever the values are single, I replace with the 0. So rest of the values, that means married and divorced, I got to replace with 1. Okay. You see the marital status. Earlier the marital status values are married or single or divorced, whatever it may be. So now after I'm applying some function, I converted the categorical value into the, now you see it is a numerical value. The same way we have to apply almost all the whatever the column we want to apply. You see, this is the another one method. For example, other loan. The other loan, whether you have the other loan, normally will give the value yes or no. So yes, I replace with 1 and no, I replace with 0. Now you see other loan also. Earlier we are having that yes or no. Now we have to replace with it 1 or 0. Similarly, for example, job. So these are only 2 values are there. You see only 2 values. So I can replace 0, 1 or 1 or 0, 1 or yes or no also I can replace 0, 1. Suppose some attributes we are having the more values. For example, you see here job. The job is having more values. What are the values? Government, self-employed, student, something I don't know, unknown or private, housemaid, retired, ex-service. So lot of values are there. So here we cannot use only the zeros or 1. We need more values. So in that situation, I am using the dictionary. I am using the dictionary. So for example, you see unknown value NP is a numpy. The NP that numpy I am using the NaN. So I replace with the NaN value. Unknown, because unknown means there is no unknown value. So I cannot able to give the some value. So government I got to give 0. Self-employed I can assign 1. Student 2. Private 3. Housemaid 4. So now I am assigning some number to that categorical values, because here we are having more categorical values are there. So that only I am using some dictionary concept. I am not using that just a simple replace. So this is a dictionary is nothing but some key value concept. Okay. So here that I am designing the dictionary. So now you see the job 0, 1, 2, NaN means unknown value. Unknown value we are replacing with the NaN. So like that only we are replacing all the value. Similarly, your education also I am replacing. So this is the way we got to loan sanction I am replacing. So all the values we got to replace the value. So now this is that I am replacing categorical data into the numerical data. Okay. Now this is the method for the min-max normalization. In the theory point, In the PowerPoint presentation, I given one using the method min normalization to normalize the value. The same thing, for example, my bank balance, the bank balance, we are having the more values. For example, 65,000 also there. You see the maximum value is some 65,000, minimum value will be 500. So I am assigning the value. So maximum value and the minimum value. So I have to use the value by default. Maximum value will be assigned as a 1 and the minimum value will be assigned as a 0. So this is the formula for the min-max normalization. I replace the bank balance value within the range of 0 to 1. You see, I am normalizing the value. All the values should be in the range of 0 to 1 only. So this is the way we got to. I will share the notebook. You can understand the things. So similarly, all the attributes, whatever the attributes we want to normalize, whatever the attributes you want to convert to the categorical to numerical. So we have to process all the data. Okay. So this is the CIBIL score. Also, I am normalizing the value. So it depends upon our requirements. So it depends on where you want to feel to normalize the data. Sir, suppose some data I want to keep it as it is, then don't want to normalize. So you want to data normalize some standard format to 0 to 1, then you have to do the things. Okay. So then this is the after I completed all the data, then I stored the data into the another one file, because I opened one data, I read one data file, I read the data file. Okay, this is I process all the things. Now I am converting the CSV file to the another one. I am creating new file. Input the data is not in the proper format. So I have to handle the data missing, identify the missing value. Then I have to do the data pre-processing stage. Then I stored the result into the another one CSV file. So this is the I stored in the another one CSV file. Okay. If I read the data, then everything will be normalized the value. So this is the way how we are going to normalize the data. So another one thing is the correlation. So this is the this is one important thing. So whenever you want to do the data science or data analysis, so we have to know that what is the correlation.
Sir, when should we go for normalization of a data?
What, sir?
When should we go for a normalization of a data?
Sir, actually the normalization, suppose the range of the data are huge, sir. The range of the data is huge, range is there. 100 also there, 5 lakhs, 10 lakhs data is there. Then it is very difficult to know what is the range of values. The value should be always, we are processing the data, some algorithm, it should be normalized means, okay, minimum value 0, maximum value 1. All the values are, we got to fix in the range of 0 to 1. Otherwise, your one data is 500 and the last data may be 300, 3 lakhs or 10 lakhs means you see the huge range of data are there. So you are distribute the data. Whenever you order distribute the data distribution, the minimal value will be 100 and the maximal value will be 10 lakhs or 5 lakhs mean you see that your data distribution. It will be huge quantity of distribution, graph will be there. The cycle of the data distribution will be huge. I don't want that all the data, I want to fix it in the 0 to 1. Then you fix the data 0 to 1. You plot the data, your graph should be within the 0 to 1. Then we can see the distribution kind of thing. When we are doing the later kind of some analysis kind of work, then it should be very good. We have to analyze the data. Before that, we have to normalize the data normalization. That means it is always a good practice when we are doing for some kind of analysis work. We got to fix the data within some range. Otherwise, the range should be huge level. You don't want to avoid, I don't want the data in the huge range. I want to make it is a -1 to +1 or 0 to 1 or 1 to 5. It is not matter to 1 to 5. You can make it is 1 to 5 also or 1 to 10 also. That means your minimal value should be 1 and the maximal value should be 10. So whatever the data points are coming, all the values should be in the range of 1 to 10 only. So that is the use of, we are doing the data normalization.
Thank you, sir.
Sir? Hello. Okay, so the correlation is, what is the meaning use of correlation analysis? Then suppose I want to analyze find what is the association between the two attributes. For example, I want to know association between my salary and my experience. Salary or my qualification. What is the relation is there? What is the relation between the two attributes? Okay, so salary, if your salary is increasing, automatically whenever your qualification or your experience increasing, automatically your salary will be also increased. Suppose I am having the 10 years experience, I am getting salary 50,000. Suppose I am having the 15 years experience, so definitely your salary will be 75,000 or 85,000. So whenever your increment, your service is increased, your experience is increasing, automatically your salary will be also increasing. Okay, so the association is positively correlated. One variable salary, your experience increasing, salary is also increasing. Similarly, another attribute, for example, my weight and my experience, or my weight and qualification. Here there is no correlation between these two attributes. There is your weight and my experience, there is no relation. Okay, so then there is a zero correlation. Negative correlation means sometimes some of the attribute value is increasing, the other attribute value may be decreasing. Okay, that is a negative correlation. For example, the time I'm traveling by car, the time I'm traveling at time with the kilometer 40 kilometers per hour, and my travel speed, my kilometer vehicle speed, I reach the distance, it will take 1 hour. Suppose I increase my speed, I am traveling the speed with 80 kilometers per hour. So definitely I will reach the distance within half an hour only. Is correct? That means your car speed is increasing, your distance coverage, the time is decreasing. So that means opposite. Both the attributes are opposite. So that means it is a negative correlation. So this type of analysis, normally we will do that correlation analysis. Suppose, so this is my analysis, this is my data. Okay, this is my input data. So I want to do some analysis, correlation among the attributes. Among these attributes, what are the any correlation is there? Any correlation is there? You see that I have to plot that. So this normally this is the value. Okay, I will show the value. This is one graph. So whenever you want to plot the graph, we have to import one library. That library normally we call as the matplot. Okay, so you see now I am importing the. For example, if you want to do the correlation coefficient, if you want to see in a graph, so I have to plot a graph. So this graph is normally we called as the heat map. Okay, this graph, name of the graph is we can call this the heat map graph. So here you see the values already told you. Here right hand side you see the color, graph value. It is a +1 to -0.6. The +1 to -6. What is the color of +1 is yellow color, and the last one, the color you can see -0.6 in the color is dark green. That the meaning is the -1 differentiate, it's a positive correlation, and the zero is a light green color. So light green color is 0. That means a 0 correlation. There is no correlation. So whenever the attributes are having the correlation, then you see the value is increasing towards the yellow color. That means a positive correlation. From the light green color, whenever the color is coming towards a -0.6, that means towards a minus. 0 is the middle point, 0 correlation. 0 to 1 means positive correlation. 0 to -0.6 means it is a negative correlation. You see the color. So they see loan sanction. So loan sanction, I want to see the correlation between the loan sanction and the other attributes. Loan sanction and the employee ID, dark green, there is no correlation. Okay, and you see wherever I got that blue light green light towards the positive correlation, you see loan sanction and the salary, and loan sanction my CIBIL score, loan sanction my CIBIL score, my salary. So these are the attributes value having the some light green color. That means the loan, your loan sanction, I'm applying the loan. The result is whether sanction or reject. That attribute predicted value depends on among all the attributes, which attribute gives more impact, your salary and your CIBIL score. Your salary and the CIBIL score is more correlated with your final predicted value, that is a loan sanction. So these type of analysis, this type of interpretation, we can get it with the help of this correlation coefficient analysis with the help of the heat map. So these are the things we have to do in the data pre-processing. Okay, so another thing is the feature encoding. So this is the things I already told you, we are converting the categorical data into the numerical data. The categorical data also we have some categories there. Already we discussed the nominal data and the ordinal data. Okay, for example, I am having that value. So this is the symbol, I created one symbol. So ID bin1 bin2, so it is a binary attribute. So nominal attribute, another one is the ordinal attribute. You see nominal attribute value red, blue color. So this value there is no impact. But you see ordinal at hot, warm, cold, but this value having some impact is there. Hot means the temperature is very high, warm means the temperature is very moderate range, cold means very cold. So I cannot assign the value. So the values are having some impact is there, some order is there, some meaning is there. So this is the ordinal attribute. How we have to normalize the value? So these all the values are binary. It is a categorical value. One is a binary attribute, another one is a nominal attribute, another one is an ordinal attribute. So already we discussed a morning what are the various types of attributes are there. So these are the attributes. So these are also categorical attribute. So how to convert into the numerical attribute? For that we are using some of the encoding techniques are there. So the encoding technique is mainly used to the data pre-processing, the data transformation stage. I mentioned that one concept, that is a feature encoding. So feature encoding is used to convert your categorical data into the numerical data. So okay, so this is, you see, I'm the binary value data. So binary value data, how I mentioned that where is the binary 0 and 1s, your 0 and 1 value, I'm replacing it to 1 and 0. Binary value So binary value yes or no value, I am replacing it to 1 and 0. Okay. So this another one encoding is there. So one encoding is the label encoding. Okay. The label encoding, for example, my ordinal data. In the ordinal data, here we are using the ordinal data. Here the ordinal data, I am using some method is there. I am using some 0, 1 and 2. 0 means hot, or 1 means some warm, or 2 means very cold. So we have to assign the number some logical way. So that we can use the label encoding. You see, I am assigning some number. Another one is a 1 hot encoding is there. So 1 hot encoding the ordinal value, the same value only, but here, so wherever the values are present, that value you have to treat it as 1. So wherever the values are not present, that values you have to treat it as 0. So that means we have to include some of the columns also. That is the use of the 1 hot encoding is there. So lot of encodings, hash encoding is there. So much of encoding techniques are there, but the encoding method is used to convert the categorical value into the numerical value. Okay. And suppose sometimes what happen, your characters in the column, you are having some special character might be say. You see here, suppose whenever we are entering the value, I am entering some comma. Suppose whenever we are representing the salary, in between we are using 25,000 comma, or last time we entered the some percentages. Sometimes we are using dollar or at symbol or special characters. So whenever you have that value in between the your cell data, numerical data, whenever you are having, whether it is a first or middle, anywhere if you are having the some special characters there, that also we got to replace using the string replace. You see the method we got to replace. You see I am replacing the value ID. First I am replacing the ID. You see before the ID we are having the values in between also there, middle also there, last also there. So now I am replacing all the values. Similarly salary also I am replacing. So okay. So this is the way we got to remove the special character also. Okay. And morning we discuss the outliers, interquartile range. So I am taking the one value. I am randomly generating the number. Random integer I am generating. First number, so one maximum 50 to 100 numbers. Okay, 50 to 100 number I am generating. First number first one, and the last number maybe 100. Maybe I am generating the 50 numbers. Okay, here in the random integer I have to select the what is a Q1 and what is a Q2 and what is a Q3. Then I have to find the value IQR value. I am calculating the IQR value. So what is the IQR value? 41.2. So what is the outlier? So this is the formula. So morning we discussed. So according to the data set, so value below minus 32.825 and above 132.125 is the outlier for this data set. For this data set, the values are above or below this range is the outlier. So this is the way we have to use the data pre-processing. Okay. So now we will switch over to my presentation. I will share the notebook, you go through. So what are the data pre-processing there? Inside I am giving the text for that particular each command, I am giving the text also, or you can get it the help from the online also. All the commands you can easily get it. You practice, then you may get more idea about the particular. I am using one attribute, you are using another one attribute. You created one Excel file, you created your own data set. Then you practice, then you may get the more idea about for that all the commands. Okay. So morning we discuss up to that this level. Morning we discussed. So we will continue from here. So the theory part. So what are the machine learning algorithms are there? Then what is the pre-processing? So I downloaded data. I have one data set. So first I got to pre-process the data. After pre-processing the data, I am using the data for building the model. That means using the machine learning algorithm, I am building the model. The model will use for the some prediction analysis. So that further analysis, further result decision taking, I got to use that with using the model. For that only we got to construct the model. So whenever we are constructing the model, so the model in the sense we are doing the one classifier. Okay. So for that we have to do the some steps. Some sequence of steps are there. The steps order should be like that. You cannot do your own. We got to follow the same sequence only. First we got to collect the data. So that means we got to extract the data from the some sources. Then we got to pre-process the data. Already told you wherever we got to remove the outliers, remove the inconsistency, incompleteness, everything we got to make it sure that my data is pakka, my data is a quality one. So we got to pre-process the data. Then after pre-processing the data, so we got to that using the data set only we are going to build the model. So that data set we got to divide it into two of, one is a training data, another one is a testing data. What is the meaning of training data in the sense? So training data we use for train the model. First we got to train the model. So both are past data. The data are having the result. Okay. If it is a classification, if it is a supervised learning problem, if it is an unsupervised problem, then no need to build the model because existing past history data is not required. So if it is a classification or regression problem only we are discussing. So that we have to divide the data set in the training data and the testing data. So normally the rule is most percentage of the data normally will use for the training model. Normally 80-20 or 70-30. 70% or 80% of the data used for the training model. So we have to give more importance for training. So training in the sense, with the help of the result, we are giving the independent variable along with the dependent variable. That means attributes and the result attributes also using all the data, we have to build the model. Then we have to test the model, how my model behaves. In the testing also, we are using the same 20% of the data set. The data set, you are having the result also. You see the result and you check the model result, how your model is giving the result. If the model result and your existing result is matching, means your model is okay. If your model is not giving the exact same result, that means your model is having error is there. So again, you got to redefine the model. So for that only, we are using the testing the data. The testing data set is used for validating the testing the model. Okay. Then we got to do some the descriptive analysis also. We got to do what is that, how your data are distributed, what is the mean, what is the standard deviation, what is the maximum data, what is the minimum data, how any outlier is there, what is the range of the data. So everything we got to analyze with the help of that some descriptive analytics. Then we got to build the model. So okay, your data is ready, all the things are ready. Then we got to build the model. Finally, we got to build the model. Then we got to model some diagnostics. We got to do some model diagnostics. So after that, we got to validate the model. Okay, I am using one algorithm. Using that, for example, I am using the decision tree, or I am using the Bayesian classification, or I am using the support vector machine, or I am using the linear regression, or logistic regression, or multiple linear regression, random forest, whatever may be the algorithm. You are using that algorithm to build the model. Then I have to validate the model, how my model is accuracy, how my model is predicting, what is the evaluation, what is the measurement, what is the assessment of the predictiveness. The model is predicting how far it is good, so that we got to evaluate or assess the model. So for that only we got to use some of the measures, we got to use some of the metrics used to assess the particular model. So once everything is okay, then only we got to use for the real scenario. So real-time implementation. So that means we got to deploy the particular model or particular classifier. So this is the things we got to do. So first you collect the data, pre-process data. So divide the data into the training and the testing data. Then we got to perform the some diagnostic and descriptive analysis as well as the diagnostic analysis. Then we got to validate the model. So once everything is okay, if you are satisfied with all the criteria, then finally we got to deploy the model in the real situation, the real data. So here I am giving some of the machine learning problem. For example, I want to know the sales prediction analysis, stock market exchange prediction, or weather forecasting, or rainfall prediction, or air quality. So your Delhi is more polluted city. Okay, Delhi, I want to predict that what is the air quality of that particular Delhi city. So suppose I want to do some the credit card transaction analysis, or I want to do some medical prediction analysis, heart or diabetics or cancer, whatever the health issues prediction analysis, whatever the predicting kind of analysis is you required. So we have to follow the model. Prediction in the sense future. Whether I have the chances for diabetes. For example, my mother is having the diabetes or my father is having the diabetes. So what is my prediction? Whether I have the chances for prediction of the particular diabetes 1 or diabetes 2. So this kind of prediction analysis we can do with the help of these kind of stages. Okay. So whatever we discuss, the same stage only. So first we got to collect the data, then clean the data, then analyze the data, then using the data we got to train the model, then test the algorithm. So finally we got to use it. So your total stages we got to divide into 2 steps. One is a training step, another one is a testing step. Okay. So and one more thing, whenever we are building the model, we have to check the model, how the model behave, whether my model is overfit or underfit. So my model should be optimal. My model should be best fit. Here the thing is, you see, so this is your model, the straight line, it is a model. So this is the actual data points. So this is the actual data points. Okay. So you see the gap, the data points, our model prediction value, more gap is there. That means a error. More distance is in the sense error. That means your original data points and this is your model predicted value. In between that, some most of the data points are very long distance. Okay, that is underfit. That means your model is not fitting the particular data point. But in the last part, you see it is a overfit. You see the diagram. Your line is touching almost all the data points. Then you can say that, sir, then why you are saying that this model is not good? If it is overfitting, that means whatever you train the model with the existing data set, exactly the model will behave particular data set. So whenever some slightly deviate one data point is coming, your model will not support. Because your model is optimal for almost all the existing data points. You see exactly it is touching the data points. That means maybe your data set is very low. You are using the very huge quantity of the data set. So that means your model is supporting almost all the data points. Whenever actually what is the use of that model? Whenever one unknown data is coming or new data is coming, your model has to predict. Your model has to take some decision. So, but this model, it will predict, it will existing the same data set only. So whenever any data set is slightly deviated data set will come, it won't accept. So I will tell one simple example. For example, so whenever we are everybody we are having the house. Okay, in the house, in front we are having the one gate. In the front, one main gate door will be there. One main gate will be there. Okay. So presently I am having one car as well as the one bike. I am having the one Alto. I am having the one small Maruti Alto there and one bike also there. You see the what is the size of the Alto according to the Alto car, and I have the bike built the one gate. So after 2 years later, I am planning to buy the new car. I am planning to buy the new Innova car. So whenever you are planning to buy one Innova car, so definitely your gate will not accommodate. So what do you have to do? You have to break the wall. You have to break the wall. You have to build the some little bit bigger gate. Otherwise, you can't. The car will not come into the house inside the campus because you built the model exactly the earlier data. So earlier I have the Alto car and the bike. According to I built the model. According to I built the gate. So whenever your car, your input data is coming, suppose somewhat higher than. So we have to accommodate the data, but your model is not supporting because already you trained the model with some small quantity of data. So your model will not support the some other slightly variant data. So that only your model, you see the optimal fit, the best fit, you see the model, it is not highly deviated, but small error is there. That means the model will support very closer to the data point also. So always whenever you are building the model, your model should not be underfit and your model should not be overfit. Always your model should be optimal fit only. So we got to evaluate that also. So these are the things. So we got to consider while we are constructing the model. You see, so one thing we got to discuss. Actually, my afternoon presentation slide will be the predictive analytics. So what is the meaning of predictive analytics in the sense? So predictive in the sense we got to think the future. Predictive using the past data, we got to predict the future. Okay, so there is a predictive analytics. So predictive analytics mostly we are using daily. You see, whenever we are planning to buy one mobile, so most of the people nowadays we are buying either through Amazon or Flipkart only. So very rare people only we are going to the shop and buy the mobile because we are getting some discount and lot of benefits are there, but a drawback also there. But some rate comparing with the direct buying the shop, less price in that online. Okay. So whenever we are and we have to get the latest model will be also available. So if you are buying the mobile, first you will not give directly order. What we have to do? We got to see the customer review. We got to see all the feedbacks, all the ratings. You analyze all the features about all the model. So what is the battery time? What is the lifetime? What is the camera features? What is the processor? What is the RAM? What is the hard disk? Secondary storage? You see all the features about the particular mobile, along with the user rating, along with the user feedback. Then only we are going to take one decision. Is correct? You analyze the past data. Then only you are going to take the decision. So that type of analyzing the past data, past user history, user review. So that is only we are using that data, we are processed, then we are taking the decision. So whenever we are preparing competitive exam also, we are studying, analyzing the past year question paper. Suppose in your research also, in our research major part is the literature review. Is correct. Whenever we are doing the research work, in our research work also, most of the time we are taking so much time for the literature review analysis only. That means we are referring the old papers. What are the methodology they are using? What is the algorithm they are using? What is the result? What is the accuracy? So after that only we can able to proceed to the next level. So that means in our predictive analytics, if you are doing that, it is always our part of our life. That means predictive analytics is nothing but first we got to analyze the past data, then process the data, then only we can able to take the particular decision. So these are some of the example. I don't want to take more time. So whenever I already told you, whenever you have to do the one analysis, always we have to follow the next also. Whenever you are doing the predictive analytics, so we got to first complete the descriptive analytics, then we got to use some machine learning algorithm. We got to build the model with the help of the machine learning algorithm. So that will give us some prediction kind of things. Okay. So this is some descriptive analytics, some example. For example, so this is one the last 2 year data. Okay, last 2 year the sense. For example, Bajaj Pulsar bike sales in the 2 regions. Okay, the different region, total 6 regions are there, and the data is we are combined the data, we are collected the data and plotted as a graph. The data are 2 years data, 2015 and 2016. So this analysis will give you see the graph. After you are seeing the graph, what is coming into your mind? Coming compare with the region 2. So rest of the all the regions your sales is increasing. Is correct, because 2015 is a blue color, 2016 is a pink color. You see the both the data sales. Other than region 2, almost all the regions are your sales is slightly increasing. Then what happened to the particular region 2? What is the reason? Whether the people are not working, or the whether particularly the really the area is there people they are not interesting to the Bajaj bike. So we have to do that some analysis. So these type of analysis normally we call as a descriptive analysis. What happened? What happened to the particular region? Why my sales down? So this type of analysis normally we called as descriptive analytics. So for doing the predictive analytics, so before that we have to complete the descriptive analytics also. So this is the how we have to use the descriptive analysis. Means we have to take the historical data using the predictive algorithm or machine learning algorithm. We are built the model. So using the model, whenever your new data will come, the data will give the result. That data, your model will give the prediction. So this is the case. This is the normal scenario we'll use in that for the your predictive model. Okay. So this is the one of the pillar of predictive analytics. So this diagram is IBM from the IBM. So last year they revealed that some of the what are the topmost predictive analytics field. So they identified 3 areas. One is the customer predictive analytics, one is the customer analytics, one is the operational analytics, another one is the cyber crime related attacks. Okay, analytics. So customer, because nowadays most company, because you see in the mobile phone you see, so every week or day to day, all the company, whether Samsung or Vivo or iPhone, whatever it may be, they are releasing lot of models. Every month or every week they are updating the model. Why they are not keeping the same model for a long time? Because the customer taste. So the customers, because our user, we are not satisfied with one model. So one mobile more feature, the camera facility is there, more storage is there. So every model mobile, they are doing the different features. That means they are analyzing the customer taste. They are analyzing the customer oriented analytics. So that type of analytics are nowadays the first thing, that is the customer analytics. Okay. So operational analytics, whenever you are running the business, so what are the, we have to take care. We have to think about how much staff we got appointment, how much profit is there, how much machinery I got to equipment, I have to spend that, how much spend I have to give the salary, how much manpower is required. So this type of analytics normally we call as operational analytics. So another one is the cyber attacks. So cyber also nowadays more kind of cyber crimes are increasing. So that also the cyber field also the cyber our predictive analytics playing the important role. So these are the 3 topmost predictive analytics area identified by the IBM. So now I will share some of the case studies. For example, credit card predictive analytics. What are the simple case studies? What are the where we have to use the some credit card transaction? Okay, so whenever we are doing the transaction, normally we will swipe the card. Is it correct? Whenever we are credit card transaction in the credit card swipe machine, we have to swipe our card. So if you are entering the correct PIN number, they will check the PIN number. If you are entering the correct PIN number, immediately will succeed. Suppose I am using my PIN number as my password or mobile car number. So further only everybody we are saying that don't use the PIN number as your date of birth or your vehicle number. So some of the people and maybe they use their number. Then the third party, sometimes they may I got one card. So if I tried with some number, sometimes it will match. So what happened? The terminal level they are checking with your PIN number. If the PIN number is matching, so it will succeed. It will proceed to the next level. Is correct? So in the terminal level, if you are not entering the proper PIN number, so that terminal itself, your transaction may be rejected. So once you are entering the correct PIN number, your transaction is allowing to the next level. So after that, so my transaction, everybody transaction, some history is there. My transaction history. So most of the time, transaction will not exceed 10,000. Or some of the people transaction it will not exceed 50,000. Or most of the transaction I am using evening only, or I am using the holidays time only. So every transaction, they have some history details will be there. So that means that some metadata information will be there. So using that information, they may check. So okay, presently that transaction it is exceeding the some limit, limit. Normally, whenever you are using some international transaction, normally we will not use our credit card for the international transaction. So you see, whenever you are using that, doing some international transaction, at the next moment, definitely you may get a call from the particular service provider, particular card provider, SBI or HDFC or ICICI, whatever your bank. So definitely we may get the call from the concerned bank because your transaction, you are doing some that international transaction. Similarly, so whenever your transaction history, the score is exceeding the level. Already we have the one score, the score, fraud score will be there. So when the score is exceeding, immediately we are getting some alert. So this type of analysis, this type of processing, the using with the help of the some prediction analysis. And this is the one of the Kaspersky. Everybody we know that the antivirus lab also. It is one of the antivirus. Their lab also they are using to identifying that whether my mail is a malicious one or it is a genuine Benkin one. So that also they are using the some predictive model. That is a machine learning based approach only. So this is the, for example, I want to identify the patient data. So I want to do the e-healthcare system. I want to use that my machine learning model to build the e-healthcare system in. So I have to get the data. All the data is some sensor data, either the ECG sensor or EEG sensor, pressure sensor, temperature sensor. I'm using all the temperature sensor data. So using the data, I have to build the model. So using the data, so I got to predict whether there's a chances for particular one disease. That means almost all the real-time applications, your machine learning is coming into the picture. We are using the machine learning for building the model. So that model will use for the some prediction kind of analysis. Okay. So this is the second level. So what is a machine learning? What are the algorithms are there? What are the way we have to build the model? So that means before the processing, then we have to build the model with the help of the some steps. Then what are the some case studies, some real time, some examples we have to share. Then we will see. Once we build the model, we have to evaluate the model, whether my model is giving the more accuracy. What is the accuracy level of my model, whether model is okay or not. So that we have to use some of the metrics. For example, when you are writing the exam, at the last result will be there. If you are score the pass mark, if you are scoring above 60 or 50, then only we can say pass or fail. Similarly, your model, you are doing lot of steps processing. End of the stage, because whenever we are doing the research also, at the end we got to prove that your algorithm is showing better than the existing algorithm. Then only your paper has been accepted some journal. Is correct. Already existing algorithm is there. You are doing some new algorithm. You are developing new algorithm. Your new algorithm has to produce the better result than the existing one. How we have to measure? We have to use some metrics. Similarly, here also in the machine learning concept, in the classification problem or prediction problem, we have to use some of the metrics to evaluate the model. Okay. So what are the ways normally we have to use? That means collect the data that I already told you. Training data. Then we got to identify that any outlier is there. Okay. We got to identify that any outlier is there. We got to remove the outliers. Then we got to partition the data into the two parts. One is a training set, another one is a testing set. Then the training and testing set normally we will do the 80-20 or 70-30. Okay. So I partition the data set. Then we got to find the what is the entropy level of the data. Okay. What is the purity level of my data set? The D is nothing but your training data set. You are taking the one data set. Using the data set only, we are going to build the model. So for that model, we got to find what is the entropy value of the model. So entropy is nothing but the purity level. What is the purity level of your data set? You see, you are taking one data set. The data set having the last attribute is the class label. Already I told you the last label is the class label attributes. Okay. For example, my prediction analysis whether bank loan sanction or reject, bank loan application form or bank loan prediction problem. Okay. The bank loan prediction problem, the last column is a sanction or reject. Similarly, credit card transaction, credit card fraud. The credit card fraud transaction analysis. So my last column will be whether my transaction is fraud or my transaction is genuine. Similarly, COVID-19 analysis. So my last predicted output is whether I have the positive or negative. So that is a class label. In the data set, how the class labels are there? How many class labels are there? For example, you see the one data set. My data set I am having the problem is particular whether cancer prediction analysis. You imagine that my research problem is cancer prediction analysis. Okay. So I downloaded the cancer data set. Generally, you think the data set, 1,000 people data are there. The 1,000 data, hardly 10 people only they may affected the cancer. Is it correct? It is a real. Most of the people, almost 90% of the people, they are normal people. They don't have the cancer disease. There's no symptom for cancer. So hardly 10 people only having that particular disease, cancer. So then you see that your data set, 90% of the data sets are belongs to one class label. Only 10% of the data set is belongs to the one class label. Similarly, credit card fraud. So most of the transactions are normal. Very rare transaction only fraud transaction. So that means your data set is not balancing data set. So for that, what is the balancing level of the data set? So that we have to check with the help of the calculating, finding the entropy value. Here, this is a formula E of D. So this is somebody you may know that already. Normally in the data mining, you studied this one. So here PI log to PI is nothing but the how many class label. Okay, how many class label we are using. So PI is nothing but number of class label. For example, credit card transaction, fraud or genuine, only 2. COVID-19, whether positive or negative, only 2. So the class level will be P1 or P2. So using that class level, using the data in the formula, you can able to identify, calculate the what is the entropy value. You see, I'm having one data set. The data set having the 100 data points are there. The 100 data points, so 30 points are belongs to positive class, and the 70 are belongs to another one class. So now I am checking that what is the entropy value. So you see 100, so that means 30 by 70, another is 70 by 100. Sorry, 30 by 100 and 70 by 100. So I converted to that tens. So that means 3 by 10, another one says 7 by 10. I am substituting the value in the formula. So I am getting the 0.88. So 0.88 is the entropy value of this data set. So what is the value? What is the meaning of the particular value? So that means there here the entropy value is 0.88. So what it value tells us means, if all the record, always the entropy value should be 0 to 1. The entropy value should be 0 to 1 only. If all the records are belongs to same class, then your entropy value will be 0. If the values are, you have equally distributed the data, then your entropy value will be 1. So what is the meaning that? You see the diagram. So here, left hand side is entropy, right hand side is a class label. You see that here the left hand side, what is the one circle is there? In the circle I put at the minus. That means I have the one data set. The data set having the 2 class label, one is a minus and a plus. So in the left hand side, I am taking the data set, all the data sets are minus. Then what is the meaning that your entropy value is 0. The right hand side, you see the data, all the data are plus. That means a positive class label. That also your entropy value is 1. You see the middle one, exactly 5 plus and 5 minus. That means your class label, your entropy value is 1. So what is the meaning that whenever we are taking one data set for building the model, your data set is belongs to the same class. What it happened? For example, I use the model. All the my data set is negative means my model will behave exactly 100% with the negative data set. So whenever, because I use the build the model with the same one-sided data set. So I am using either positive or negative. Then the model will behave. The model will react according to the particular data set, because we are not giving the other option. We are not giving that other sided data. I build the model always with one-sided data only. Then the model cannot react to that another one situation. The model will, it knows only the one-sided data. Whenever you are giving the negative or positive, it will give exactly proper result. Because we are not giving the, we are not using the some other sided data for building the model. Okay. Suppose whenever new data is coming with an unknown value, unknown new data, the model cannot predict. The model cannot able to say what is the result. So that only always your model should be, the entropy value of the data set should be towards the 1. That means, so whenever your data is having the almost one-sided, either positive or negative, that means the data set is an imbalanced data set. So your data set should not be the imbalanced one. Your data set should be balanced one. So whenever you are getting the data set, it is a imbalanced data set. So you have to convert the data set into the balanced data set. Otherwise, your model will not predict, your model will not behave about the another type of the class label. So you are better always the entropy value of the your data set should be closer to 1. When it is closer to 1, you see the data set, you see exactly 5 plus and 5 minus, then the value of the entropy will be 1. So that means your both the class labels are exactly equally distributed. So we have to make it sure your data set should be equally distributed. Okay. So that is a 1. So that means this is the first step. We have to find the entropy of the value. Then, so whenever we are building the model, we have to identify that some of the terminology we have to use. So what is the main interest of the class? What is the main interest of your class? For example, it is a medical data. So whether the particular patient having the disease, identify the disease is the main interest of the class. Okay. Whether I want to check that whether you are having the COVID-19 positive or negative. My intention is, main interest is whether you have the particular disease, whether you are having the positive. So that is the main interest of the class. So we have to identify that what is the main interest of the class first. So for example, I want to whether my loan is sanction or reject. Here the sanction is the main interest. Whether I am applying one loan, whether I have get to the buys a car or getting I want to buy building a home. So that means it is a yes, buys home, yes, is a main interest of the class. So depends upon the problem, the main interest of the class will be different. So we have to identify that what is the main interest of the class. So that class label data normally we call as a positive samples. Opposite will be the negative sample. Okay. Then we have to use some of the terminology while you are assessing the particular model. So what are the things? True positive and the true negative. Okay. So what is the thing? First we got to construct one confusion matrix. So what are the parameter we will use in the confusion matrix? Means true, four parameters, four values are there. I will tell you what are the values. One is a true positive in the sense already the positive samples. So that means I am building the model, I am checking the model with that already data. Already the data original value is a positive sample. My model also predicted as a positive. Then it is a true positive. Original data, the data set is having the class label. The output is there. The output is also correct. My model predicted output is also correct. Then that value we call as a true positive. What is true negative? Already the data set having the negative samples. That means there is a zero result. What is positive? Positive. Negative sample also your model is predicted as a negative. Then it's a true negative. Negative value is predicted as a negative, true negative. Positive value is predicted as a positive. Then it's a true positive. So this is opposite. Opposite in the sense false positive. What is the meaning of false positive? Means negative sample. Originally the values are negative, but your model, your classifier or your regression model is predicted as a positive. So that means it is not a original positive, it's a false positive. Originally negative. For example, I'm not having that COVID-19. I'm not having the COVID-19. I'm a normal person, but your model is predicting me as a positive, COVID-19 positive. Then it is also danger. I'm a normal guy. I don't have any disease. Originally, that negative, am I having the COVID negative only? But your model is saying that I am affected the COVID-19. So that means a false positive. Originally negative, your model is predicted as a positive. So it is a false positive. Similarly, false negative. Originally positive, it is predicted as negative. Originally, I am a COVID-19 patient. I affected the COVID-19. But your model is saying that you don't have any disease. You are the normal guy. So that type of prediction called as a false negative. So our intention is we have to avoid, we have to minimize the false positive, another is the false negative. So normally these two error we called as the type 1 and the type 2 error. Normally in the machine learning approaches, there are two errors are there. We called as the type 1 error, another one is the type 2 error. What is it? This is one simple interesting diagram. You see, so this is the graph. This is the matrix, confusion matrix. So this is a predicted value, another actual values. You see, one lady is pregnant. Okay, one lady is pregnant. The doctor is suggest doctor is the model. Here the doctor is a model. The patient is the original data. So the doctor also saying that you are pregnant. That means your output original value also pregnant. She is pregnant. Your doctor is also predicted that pregnant. Then it is a true positive. Your positive data is predicted as positive. You see the diagonal. True negative. One gender is there. The gender is not a pregnant. Your doctor also saying that not pregnant. So negative samples predicted as a negative, it is a true negative. You would see the opposite diagonal, false positive. You see the one gender, normally gender will not get the pregnant, but your model is saying that pregnant. Your model, your doctor is saying that pregnant, but he is a normal gender guy. So, okay, that means it is a false positive. Originally negative, but your model is predicting as a positive, it is a false positive. That type of error is a type 1 error. So, what is type 2 error? Originally the lady is pregnant, but your model is predicting that it is not a pregnant. So, this type of error is the type 2 error. Sometimes in our research problem, so in the type 1 error we called as a false positive. Type 2 error normally called as a false negative. Suppose whenever you are doing the research, so I want to more focus on the false positive, or I want to more focus on the false negative data, because your model will say that. Suppose some of the model will give more on the false positive, or some of the model will give more data, more result about the false negative. So what type of analysis you want to do? So before that, you have to make it is clear that what is the meaning of false positive. So what is the meaning of type 1 error and what is the meaning of type 2 error? I hope you understand the concept. Okay. So that value we got to predicted the confusion matrix. So here I am using the confusion matrix. Here you see it means it is an actual value and it is a predicted value. I am plotting that both the value in the graph. So both are correct, true positive. Both are negative, also true positive. So your diagonal true positive and the true negative is a good manner. and the false positive and false negative should be the opposite. That means we have to minimize this value and we have to increase the value. Okay. So this is that some symbol we have to use that. I have to plot at the value. How you are plotting the value? If your model is right, means we have to increase the value of TP and TN. If you are reduce the value of FN and PP. If your model is giving more value on FN and the FP, means your model is worse. Your model is not giving the proper result. So our ultimate aim is we have to build a model. That model will give more result on TP and TN. So using this confusion matrix, this is first we got to know about that value. What is TP? What is FN? What is FP? What is TN? Okay. So using that, after you identify the value, after the value in the matrix, that is a confusion matrix. So after the confusion, construct the confusion matrix, we got to use the sum matrix. So what is a metric? That means one is the accuracy. Already I hope now, whenever somebody already you run the machine learning algorithm, whenever you are running the machine learning algorithm in the Python or somewhere, your last stage you may get some accuracy. You will get the accuracy, precision, recall. So these are the values normally called as the measures, accuracy measures or the metrics. So these are the value only to give the how your model is behaving. So what is the meaning of accuracy? You see here the values. You see totally 10,000 records are there. Okay, 10,000 records are there. In the 10,000 records, 7,000 records are positive yes, and 3,000 records are biased computer no. So what is the meaning of here 6954? Your original value also yes, and the model predicted value also yes. Among the 7,000 record, 6954 records are predicted exactly correct by your model. So total actually yes is 7,000, but among that your model and the original value both are 6954. So what is here is that 25888. So among the 3,000 data, 2588 data, your model is predicted as true negative. So what is the 46 here the value? Among the 7,000 record, the 46 records are predicted as a false negative, originally false positive value. So what is 412? Among the 3,000 record, the 412 records, 412 records are predicted as a negative wrongly. So these are the things I have to plot at the value according to the value. So then you apply the formula, how to calculate the accuracy, TP plus DN divided by P plus N. So accordingly, I got to get the value 95.42. So whenever you are running the value, you are getting the value some accuracy. The value is internally calculated using the method only. So this is the accuracy 95.42. Then it is almost okay. My model is giving 95.42 result. Okay. So this is the accuracy. Then another is the error rate. Error is nothing but 1 minus accuracy. So when the accuracy is in a good manner we are considering, error rate means negative manner we are considering. So accuracy is nothing but 1 minus accuracy. So here earlier problem, what is my accuracy? Accuracy is 90.542. So then what is the error rate? Error rate is nothing but 4.42. Okay. So this is the one matrix. And another one important thing, we cannot always use that accuracy as the measure, because whenever your data set is balanced properly, then you can go for the accuracy. So when we cannot, suppose most of the data sets are imbalanced data set. Earlier we discussed, for example, cancer data. You see, so patient 1 is having the patient having cancer, 0 is means the patient not having the cancer. You see the data set 9,990 records are positive record. The patient, their people doesn't have the cancer. Only the 10 people only having the cancer. So if you are using that particular data set for building the model, always your model will give the more accuracy. Whenever you are giving the good patient data, your model will give a correct result, means then we can say correct. If your model will see the wrong result also, then it will not give the more impact about the result, because your input data is only 10% of the data only. So always if the model will give the 99.9%. If you are giving that wrong result about the particular opposite data also, because your input data set is having the very less number, because when we are substituting the value, your value is only 10. So 10 by 10 also it will give the 1% only. If we all are wrong also, it will give the very less number of result only. Is correct. So that means this measure accuracy we cannot always follow for the prediction analysis. So for that only we got to use some other balance. Okay. So another one earlier we discussed. Suppose my data set is having that imbalanced data set. So we got to use that. We got to convert it to the balanced data set. For that only we are using the bootstrapping is one of the important method. In the bootstrapping, what we got to do means we got to resampling, either upsampling or downsampling. You see the credit card transaction data. So most of the transactions are genuine. For example, I am having the 100 transaction, 90 transactions are genuine. So 10 transaction is fraud. It is an imbalance. So I want to balance in the sense, two way we can balance. What is the one way? I got to increase the negative fraud transaction. I got to increase the more. In the 90 transaction, I got to increase some 70-60 transactions for fraud means balancing. Is correct. One way. That means that is a increasing the minority class. That means that is a upsampling. Downsampling in the sense. So in the 90% of data, I am reducing the size. I remove the 90, I remove the some 40, then or 50, then it is a 40-10. So one way I have to increase the minority data set. Another way I have to decrease the majority. Our intention, our game is we have to make it is a balancing. Is correct. So both of them are running. So one way I got either I got to follow with your speed or you have to down your speed. It should be matching. So whether we are increasing that minority data set means then we call this upsampling, or we are reducing the sum of the majority class labels, we can say it is a downsampling. So these are the some of the method k-fold cross validation bagging. So these are the some of the standard method normally we use. So most of the application we will use the resampling. Either we have to use the upsampling or a downsampling for make the data set into the balancing one. You see, so this is the imbalanced data set. What is the meaning? That your class label, you see the class label blue color dotted means more dots, more classes are there, more class labels are there. And another one is a red color. So the red color in the sense, what is the meaning? That very minor, more data sets are there. So I'm undersampling means, you see what is the meaning of undersampling? I remove some of the majority class. I'm removing the some of the blue color. So you have to make the both colors are equal. Oversampling means I have to increase that the red color. That means the minority class level I am increasing. So now you see both are balancing. Either we got to do undersampling or we got to do the oversampling. So any one way we got to make it your data set should be balancing. What are some other accuracy methods are there? So whenever your data set is imbalanced data set, so then we got to go for the some other methods, accuracy method. We can call it as a sensitivity. So sensitivity is nothing but we got to use that model. What is the model we are using? Suppose TP by P. So what is the time now? Okay. So this is the sensitivity is the one way. So this is the formula. Already everything we are taking the value from that particular confusion matrix only. Okay. So already we got to first we got to plot the value, then we got to use the formula. So sensitivity and another one is the specificity. So whenever you want to give more about the true positive rate, or whenever you want to give more intention about the true negative rate, so then we got to use the sensitivity and the specificity. Okay. So this is the formula. So this is the, for example, on the cancer database. So in the cancer database, so I am using the, what is the formula? Sensitivity I am getting 38%, accuracy I am getting the 96% percentage, specificity I am getting the 98.5%. So that means here we have to consider only the sensitivity is only the measure, because sensitivity is mostly used for the true positive. So here your data is not giving the more accurate result about the true positive. So that only the measurement accuracy value is very less. Somewhere we have to use that specificity. Whenever you want to give more importance about the true negative rate, so we have to consider the formula specificity. So according to the matrix, we have to use, depends upon your requirement, whether we want to go for the accuracy or we want to go for the sensitivity or you want to go for the specificity. Somewhere, so this is another one method, that is a precision. Another way is the exactness. Whenever you want to more focus on the false positive, it is almost similar to the sensitivity only. So more positive, false positive means we have to use the precision as the one of the measure. Similarly, another one is a recall or completeness. So whenever you want to more about the false negative, so you have to use for the recall. So these are the sum of the measure. Or I want to mix it of both the false positive as well as the false negative. Both I want to mix it together means, so we have to use that F1 score. Normally, these are the things you have to get it from that when you are running that particular own applications. Okay. So when to use that F1 score, whenever you want to positive, negative, and negative should be classified as a positive. I don't want to classify it like that. Then we got to consider the F1 score. So another one important measure is there, then the ROC and the AUC. So ROC is nothing but a receiver operating characteristics curve, and AUC means area under curve. So this is the, whenever we are modeling, only one threshold value earlier we are considering. Instead of one threshold value, we have to considering the some range of values. We have to plot the value within the range as a curve. According to the curve AUC value, we got to predict that what is the accuracy level. So normally the values should be the 0.5 to 1. So whenever the values are starting the value, AUC, ROC value will be always in the range of 0.5 to 1. 0.5 means it's a bad classifier, 1 means it is a 1 classifier. So we have to plot the value between the two rate. One is a false positive rate, another one is a true positive rate. The values are 0 to 1. The values are 0 to 1. 0 to 1 means 0.52, it will give the value to the 1. According to that value, we can be able to identify that whether your model is that more good or bad. Okay, so these are the sum of the measure normally we'll use in that classification problem. See, when these are the accuracy, error rate, sensitivity, specificity, F1 score, recall, precision. So these are the metrics we'll use in that classification problem. While you are coming to the regression problem, so we have to use the some other measure. You may have the root mean square error, mean absolute error, mean absolute percentage error. So these are the some of the metrics we used for evaluating the regression model. Suppose I am building the linear regression model problem. Okay, in the linear regression model, so what is the percentage? How I have to evaluate the particular model? So here we have to consider only the root mean square error or mean absolute error or mean square error. So this is the value. So here this diagram you will give the idea. So the red color is the model. The dot is the original data. So what is this distance? So this distance is normally we call as the error. That error we call as the SSC. And the model, this is average data points. The y dash is the average data points. So this is the particular one data point. The average data point and your model, what is the distance? So that distance normally we call as the SSR. So your average distance and the particular one data point distance both combined together we call it is the SST. So SST is nothing but SSR plus SSC. So these are the measure normally we'll use while you are evaluating the regression problem. Okay. So in the regression problem, these are the method normally we'll use. One is a mean absolute error. You see, so this is the data point. So this is your model is predicting. So the distance is error. So that error is normally we call as the mean absolute error. So our intention is we have to reduce the error. That means your model is very closer to the data model. We cannot able to fix the exactly zero value. The zero means it is a overfitted data. Some error, some value should be there. It should not be margin value. It should not be more margin value. The value should be less. So this is the formula. So this is a simple calculation. You may study this in your school standard also. Regression problem will be there. The regression, the school mathematics or by your UG level also regression problem. So some average. It is a simple calculation only. Okay. In Excel also we can solve the regression problem. So this is the formula for root mean squared error. So this is the mean absolute error. So these are the some of the metrics normally used for when we are dealing with that regression problem. So whatever problem earlier we discussed, so that these are all the metrics we have to normally use for the classification problem. Okay. So one simple linear regression, I will tell you what is the things. I will tell you the, for example, so salary, another one is the experience. Already told you. So salary is the my independent variable. So dependent variable salary. So experience and salary. Salary is determined with the help of the what is that your experience. So this is a symbol. So already you studied that the equation. So linear regression equation is nothing but y equal to mx plus c. Okay, y equal to mx plus c. So c is nothing but the your b0, that is a intercept. So b1 is nothing but it is a m, and x is the your input variable. Here e is nothing but the error. Okay, so I will give you e is error, slope is b1, and the intercept is normally we call as your b0. So if we had what is the formula, how will you calculate the b1, how will you calculate the b0? So this is a simple example. So how you have to calculate the linear regression model. So what is the formula? So how to calculate the value of intercept, how will you calculate the value of the slope value, and how to calculate the value of the error e, how will you calculate the value of the error? So this way we got to analysis the any one of the classification model, either classification model or regression models also there, we can analyze the things. So I will show one small that demo also. One simple linear regression I will tell you, then we have to go with the sum there. So this is for understanding level, simple linear regression I will tell you. So last class already we discussed that what are, so that numpy and numpy is used for the, some numerical calculation. So we got to use that for the numpy, and whenever you want to plot any graph, we got to use the matplot. Okay. So linear regression, whenever we want to build any one of the classifier, either decision tree or the linear support vector machine. So all the classifier models are available in that one library, that is sklearn. So sklearn is the one of the module. So I hope yesterday you discussed, you studied what are the various libraries are there, what are the use of the libraries for the each particular one, all the your modules, all the applications are we have to build, we have to use the particular libraries. So whenever you want to do the plot the graph, so we have to use the either matplot or we have to use the SNB. Another one is there. Whenever you want to do the some data frame kind of things, we got to import the pandas. So whenever you want to import any classification problem or in regression problem, so all the models are available skland. Okay, here skland, what is the model we are using? The linear model, import linear regression. So already I told you. So coding part is not a huge task. So already if you are writing the coding in the C or C++, we have to write the separate code for that particular one model. Here already every model is there, just to plug and play only. So I am using the linear regression model. You see here the model, what is the thing? Whatever we are seeing that I am taking the two parameter. One is a salary, another one is a experience. So salary I am having the some value, and experience I am having the some value. So okay, so your experience is your independent variable, your salary is the dependent variable. So according to the experience, how much salary I will get. Okay, so I will run the thing. First we got to, I hope everybody know that the Google Colab. So I have to connect to the things. Already I run the model. Okay, so this is, I have to build the model. First we got to create the one object, we got to build the model from the linear regression. Using the linear regression, I am building the model. So LINREG, so this is my model. So using this model, in that model only I am going to fit the data. So that model only we use for giving the some prediction. So you see linear regression is the some class prediction. Using that algorithm, using that model, I am creating one instance of the linear regression. Already you may study the class and the object concept. So from that particular one class, linear regression, I am creating one instance. Now line REG is the one of the object. So using that object, it is a linear regression object. In that object, I am going to fit the data. That means fit the model with the help of all the data. Then the model will behave according to the how you are trained the model. Okay, you see experience is the one data, and this is the, we have to actually whatever your data format is there, we got to reshape into the single vector value. So it is a for example, it is a one dimension, it is a whatever the format may be there, we got to convert the data into the, whenever we are fitting the data into the model, so you got to convert a reshape into that model into the single line vector. Whatever is the data, I am reshaping to the -1 to +1. That means a single row, single column, single vector values. Okay, now you see line, this is the object, fit experience salary. So I am giving, this is the more important, I am fitting the model, I am creating the model. That means already created the object, that model I fitted with the value experience and salary. So now, so this is I already run, I'm fitting the model. Then salary prediction from the model, what is the output, what is the predicted output value? So this is the predicted output value. So that will predict based on the, what is the input value, experience. So experience is the your independent variable. Based on the value, what is the predicted output? My predicted output is the salary predict. Okay, so this is the value I am building the model. So this is the model. So this is the, in the blue color is the data point. So experience and salary. So your model is not so much, almost very close to the model, almost very close to the data point. Okay, now, so now we got to see that whenever we want to calculate the value for linear regression model, y equal to mx plus c, that is a straight line. So y is the my predicted output, x is the my input, and m is the slope. Okay, m is the slope, c is the intersect value. So for that, we have to know the value m and c and x. So x is the your input data, your experience data. We have to calculate the value of, what are the values we have to calculate? M. So m you have to calculate, that is a coefficient value, that is your m is nothing but it is a slope value, and intercept value also we have to calculate. Sorry, c is the intercept value and m is the slope value. So that value I am calculating, and what is the coefficient value, what is the intercept value. So I am calculating the both the value according to this data set. So 4 is nothing but coefficient value, 12 is nothing but that is the intercept. Your c is 12, c is the 12, and your m is a 4 point something. Okay, now I want to know that this is a formula. You see y equal to 4.8, so that is your m value plus your your c is a 4.8x plus c is the 12, and your y is that your x value, y equal to mx, m is your 4.8. So whenever I want to using that value, I want to predict that. For example, here you see this is the experience. Okay, I'm giving that value. Suppose if I am having 45 years experience, how much is salary I will get? I may get almost 2,32,000. Suppose I'm having 20 years of experience, how much is salary I will get? I may get that 110 value. Okay, sorry, 1,10,000. So this is that. According to, we are predicting using this value. Already we built the model with the help of that. What are the value? My experience is there up to 11 years experience. I salary 2 years experience. I'm getting 25,000 salary. Suppose I am having 11 years experience. I'm getting the 65,000 salary. So this is the value. Using the value, I am building the model. Then I want to predict that how much is salary I will get when I am having the 40 years experience, and how much is salary I will get when I am having the 20 years of experience. Okay, so this is the way we have to build the model. This is a simple understanding purpose only, but the real time we have to use the long procedure is there. So then I got to find the what is a mean square. Already told you the regression problem. We have to use that mean square, any one of the method, either root mean square error or mean squared error. So what is the problem? So this error is 1595. So this is not a because our data set is very small data set. We are not having the huge data set. So that only we are getting that more error. The error is huge. So that means our model is not up to that level. Because using that error rate only, we have to be able to predict the value. Okay, we have to be able to predict the assess the model. So this model is giving more error rate because of the very less number of data set we are using. So this is the one way. Okay, I will tell you another one example also. Almost time is up. Anyway, I have to. So this is the another one prediction analysis. That means a credit card fraud deduction. So we have to do the credit card fraud deduction. So this we have to import I have to download the one data set Gaggle. So some of the, so in the last class I will share the what are the open source data sets are available. So I will discuss some of the case studies also. So these are the one of the site we can download the lot of data sets are there. One is a Kaggle, another one is there GitHub. Okay. So these are the two data sets. Mostly we have to for the machine learning applications or deep learning application, we can lot of open source data sets are there. So nowadays getting the data set is not an issue. Whatever your problem, you have to get the data set. So I download the data set. You see the data set, the attribute value you see V1 up to V28, then amount and the class. So here the data set, the attribute names are hiding. They are not reveal the data set. They are not reveal the attribute value because their data set is already they normalize the data. They are normalizing. That means they are applying the some dimensionality reduction techniques. They are applying that PCA, principal component analysis, to convert all the attribute names in the some assignment. They assigned some other value because some sensitive data. Credit card fraud transaction means which people is doing the transaction, the credit card, the genuine transaction, fraud transaction. What is the amount? What is their IP address? What is their name? So they don't want to reveal that particular information. They want to keep the some sensitive to maintain the integrity. So they didn't reveal the name of the attribute. Just they given the name V1 to V28. That means already the data set is normalized with the help of the one techniques, that is a PCA. Okay. So here how many records are there? You see 2,84,000 records are there. Is it correct? 2,84,000 records are there. So there is a no null values. Okay. And you see fraud. One means class label 1 is fraud, and the class label 0 is normal. You see the data set. Among the 2 lakhs data set, 2,84,000 data sets are normal. Only 492 only fraud transaction. That means your data set is not balancing. So is correct because most of the data sets are belongs to one class. Your opposite side class, there is only 400 data attributes are there. That means your data set is not normalized one. You see, I'm plotting the value. Most of the data are normal. Very less number of data only fraud. Okay. So that only your data, how you see the data is not normalized. Then I take the some fraction. So whenever we have to create the sample, what is the meaning of population and the sample means? Sometimes it is very difficult to handle the huge data set. I don't want to use the whole data set. Just I want to create one sample. Sample is nothing but one of the subset of your original data set. So from the original data set, I'm creating this some 10% of the data. I'm creating the 10% of the data. 0.1 means 10% of the data. That means your original data set is 2,84,000. From that, I'm creating only the 28,000 of data. So in the 28,000 of data, 28,000 is fraud genuine and only 49 record is genuine data set. Okay. So now you see, so these are the some of the histogram. You see this histogram, we can see among all the attributes, how the attributes are distributed. You see this attribute, you see V9, for example, this is the V13. From the middle 0 point, the left hand side and the right hand side, the data are equally distributed. And you see some of the data points. So this V23, so the data set is, it is highly up after 0 only. It is not distributed properly. It is a positive distributed. So that means how your data are distributed, whether your data is distributed uniformly or whether your data is not distributed, how the data is particular attribute values distributed. So that type of help we can help it from the help of the histogram. Histogram is just you are plotting the value. While you are plotting the value also, it gives some interpreting. We have to get some interpretation from the particular distribution. So already I discussed is the correlation coefficient. That also I already show you what is a minus. It is a +2 -1. Already I explained the what is the color, what is the meaning of the color. Okay. So here, then here I am using that. We have to divide the data set, a training set and the data set. Here, what are the algorithm I am using? You see, I am using the random forest classifier. Then I am using the decision tree classifier. Okay. So then here also I have to use the confusion matrix. I am using that classification report also I am generating. So I have to use that normalize the data. I have to do the pre-processing the data. You see, before sampling, I have to sample the data, because earlier how I am doing the sample, already we studied. So before, what is my data? So after sampling, whether we got to do the upsample or downsample. So these are the things we are sampling the data. So that means I'm increasing the data set. So another one important factor, we got to standardize the data. Standardize the data means we got to convert the data with the reference to the zero mean value with the standard deviation value. I think you studied this concept in the statistical earlier mathematical foundations, that concept. So when we are analyzing the data, we got to see how your data are distributed with the reference to the mean value or with the reference to the your standard deviation value, because your data should be properly distributed. You see, your data, whenever you are analyzing the data, your data should be, we got to plot the data as a bell curve. That means, so before and after the 0 to positive side also, negative side also, you have to equally distributed. Then only we can able to process the data. Then only you are build the model, the prediction analysis will give the more result. You see, before standard scaling, you see how the data are distributed. It is not, there is no reference with the mean value. Now after standard scaler, you see the data, all are, we are mapping, we are transforming the data with a range of mean value, with the 0 mean value and with the 1 standard deviation factor value. So that is a standard, how you got to do the standard deviation value. So this already we studied that how you got to construct the confusion matrix. So this is the confusion matrix, and what is the accuracy? You see, so we discuss some of the metrics. Okay, what is the accuracy? What is the precision? What is the recall? What is the F1 score? So particular this model, what is the value? Okay, so this is a formula how you are converting the value. Similarly, all the models, so outlier detection also, the morning I discussed, I told you the isolation forest and local outlier factor. So these are the value used for identifying the outlier. Whenever you are having the huge data set, so we have to use this method for analyzing identifying the outlier analysis. So morning the theory class, I told you isolation forest and the local outlier factor. So these also we can use for how to identify the value. Okay. So after the observation, so here which model is giving the better result. So according to this particular data set, comparing with the LOF, your isolation forest is giving more prediction, more the outlier prediction result. So and we are converting the balanced data set to the how to balance the data. So that means here also told you. So earlier you see my data set is 10,000 and 31. That means 10,000 one sample and the 31 is another one sample. So I am upsampling the data. After I am upsampling the data, that means now you see. So 28,000, we are increasing the another one instance. I am increasing that instance in the sense we cannot randomly add the things. So whatever the existing instance are there, the same instance only we are creating the sum of the duplication. Okay. So this is the way we can do the sum of the prediction analysis. So I will share this notebook also. You execute one by one, then usually you can understand that all the commands, how it is working and others. Still, if you are having any doubts for the executing these commands means, the last day we have one more session. That session we will clarify all your doubts. Okay, here I will stop my presentation. Hello. Hello, sir. Sir, I will share all the notebooks details also. I will share 1 or 2 Python handbook also. You can practice, because some of the participants may be other computer science background also there. So for them it is very difficult to understand the thing. I will give 1 or 2 Python handbooks, and I will share some of the machine learning books also. You go through that book and as well as the Python handbook, you may get more idea.
Kumargan, thank you for the session, but it would be good if the notebooks can be shared in advance so that we all can.
We can practice. It is good, sir. Okay, that's nice comment, sir. But I don't know how many of them you are knowing very well about the particular one. I will share the notebook as a PDF. Otherwise, what to do if you are copy and pasting the notebooks, you cannot get any idea. So you type by yourself command, because some of the expert, they may teach only the Python command prompt only. Why means otherwise, because we are lazy people, sir. We are using the cut and copy. If you are copy, you cannot able to get a real how it is working, and other simply copy paste work. Really, if you are typing the command, then only you can able to understand that how the command is working.
I agree with you. That is what I was saying, that when you are explaining to us, if you can give us the notebook, we can type and check the commands also, and we can see that the results are coming or no.
Okay,
And
okay, sir. Okay, sir. I will share it.
Okay, sir. And additional request is to share also data file. Otherwise, that commands may not execute, sir.
Which one I have to share?
That data file.
Yes. Okay. Yes, sir. The CSV file also I will share.
CSV file also you need to share it.
Yes, sir. All the things I will share.
Yeah.
I will share some of the books also. I will share to you.
Yeah.
Okay.
Thank you, sir.
Okay, sir. Any more doubts in my presentation?
Dr. Morgan, for the coming workshops also, if it is possible to share these files in advance, it will be good for us. Because
Okay, sir.
when we are discussing, then that time we can have some doubts also, we can ask them.
Okay, it's correct, sir. Okay. So mostly I will share any files further my Friday session. If some applications I am planning to share on the Friday, so better I will share that application in advance.
Sir, shall we have assignment? Pandey sir, I think many of the participants are very much interested in doing assignments. Shall we give assignment?
Yes, no issues. Assignments are also good because that will test our understanding. So it's good to have assignments as well.
Yeah, I will create a Google Classroom. I will assign. Dr. Arul Valan sir will be giving the assignment, and you do that. I will create a classroom. Before Friday, you will complete the assignment. No problem.
One madam is asking.
Yeah.
For the sensitive analysis, sensitive in the sense you are talking about the sentiment analysis. If you are talking about the sentiment analysis, means we have to do along with the NLP is there. So data science, we have to combine with the natural language processing. Sir, that is most useful for the sentiment analysis, and medical image analysis we have to do with the deep learning, sir. If time permits, the last day I will show one demo on CNN. I will give some idea about the CNN also. I don't know whether Murugan sir having any session for the deep learning. The party, if any expert is already, I hope some of the expert may share about discuss about the CNN network.
Yeah. Venkatesan sir will be discussing, sir. Yeah.
Yes. That deep learning, the CNN is mainly used for your image analytics. And similarly, the time series analysis. So most of the nowadays our data are time series data. So for that we got to use the RNN. You may have that recurrent neural network. Another one is a long short-term memory network, LSTM network. So that will be mainly used for that the time series data analysis. Sir, amount of it is up to you, sir. Actually, our intention is that sampling and upsampling or oversampling, how much percentage we have to do is up to you. So because your data set should be some balancing, it should be some. It is not we cannot make it is a 50-50. At least you make it is some 70-30 or 60-30. Sorry, 60-40 range of the data. Whenever you feel the data is imbalanced data. Sir, unsupervised learning also same accuracy only. Unsupervised learning, reinforcement learning also we are using the mostly accuracy only, but there's other classes there. We are not considering the other F1 score, recall, that is will be not there. So only the accuracy normal will use for that one. Sir, sensitive analysis for medical imaging. Sir, actually, why we are going for the image classification in compared to or CNN means So deep learning network will give more accuracy, because in the machine learning we are doing separate feature extraction. Sometimes some of the feature may be more sensitive. It will give more impact for the result. So that only in the deep learning approach, there is no separate feature extraction process. Directly everything extracted with your model. The deep learning network itself, it will extract the features, so that only sensitive kind of analysis always we got to do with the deep learning kind of approach, either both CNN kind of networks. I will share some demo. I will share some demo on the deep learning the last day also, if time permits.
Okay, okay.
Okay. Sir, any other things you want to discuss? What is my, if you have any doubts personally also? Sir, statistical test means actually statistical test is a statistical analysis. I am not a mathematics strong. So before that, we have to identify that the P square, T test, that means some ANOVA test. So that is mainly used. Some the numerical data, categorical data, we are comparing with some other kind of analysis. Some the numerical data, if you are having the association between the data, we have to analyze with the P value, T value. So that will give more help for the statistical analysis. You may add the P test or T test. So that type of test normally we will do along with the statistical.
Okay, sir. I think we can conclude. I think the doubt is okay.
One more, sir. Sentiment. I don't know how you are mingling sentiment analysis and the stock market. Stock market, in the sense, it is a prediction, sir. Stock market also, it is not a classification problem. Stock market is a prediction problem. What is your stock? What is the value of the particular item tomorrow or next? So you predict the stock market value. Stock market problem is the prediction problem. It is not related to the classification problem. And I don't know how you link the stock market problem with the sentiment analysis. Sentiment analysis, it is a NLP problem, sir. Sentiment analysis is a machine learning with the NLP approach. So any other doubt? I hope you little bit enjoyed the session. I'll cover more things.
I think we can conclude, sir.
Okay.
Valan MSPT at yahoo.co.in.
I shared my PPT. I shared that mail ID also.
Yeah.
I hope you definitely in the next 2 days already you definitely enjoyed or you learned that data science. I hope Murugan sir is taken a lot of steps to arrange all the experts. I hope definitely you get a lot of exposure, lot of input from that all other experts. Okay. So thank you. We'll meet on Friday. In the meantime, if you have any doubt also, you post or keep in mind that day we will discuss. Thanks.
Okay, sir. Okay.
Wish you good luck.
Okay, sir. Thank you, sir. Thank you.
Your mail ID also.
Yes, sir.
Already shared.
In that, I will give my mail ID. My phone number is there. Personally,
Okay.
In the chat box, we have mentioned the mail ID.
Sir, I am from Tamil Nadu. Sir, actually, I am from Tamil Nadu only. My native place is Nagarkoil, Kanyakumari only. So presently, I am working in Nagaland. So you can talk Tamil also, no problem.
Yes, sir. Yes, you are good in Tamil, so you are good in English. Bilingual. Yes. Very, very good session, sir. Very nice presentation. Very informative on the presentation. Practical exposure. Very nice exposure. All the participants have asked so many doubts. They cleared the doubts, and they are very much enjoyed the session, I think. And Friday, we will be handling the session. So before that, we will assign a class.
Before that, Murugan sir.
Yes.
Sir, before that, if they want to get any more idea about any machine learning approach, let me know. So as per the session schedule, I have to share some of the case studies. I have to give some case studies about that some real problem. So before
in the WhatsApp chat, if they are giving means I will forward it.
Other than any other topic means before that you will let me know, sir. Okay.
Yes, sir.
Interest. So participants, you have any personal interest, you discuss with your coordinator. Accordingly, we will discuss on the last day, Friday.
Okay, sir.
Okay. Thank you very much.
Okay, thank you, sir. We will see you on Friday. Sir. Thank you, participant. I will share the attendance now. Thank you. Tomorrow we will discuss.